Good morning, students. Today we will again discuss the next consequences of Lorentz transformation, that is, relativistic formulae for velocities, that is, the velocity of a particle in different frames of reference and their correlation. These are also called velocity addition formulae. So, what is velocity addition formulae? These formulae are the set of three equations that correlates velocities of a particle in two different inertial frames, f and f dash. So as we know, there is a single particle which is moving in space and its coordinates are ux, uy, uz with respect to f frame, and ux dash, uy dash and uz dash in f dash frame. So these formulae will be derived in accordance with the postulates of special theory of relativity. Now, let two frames of references f and f dash, where f is at rest and f dash is moving with uniform velocity v along x-axis. Let a particle p is lying in space or moving in space. The coordinates of these particles are x, y, z with respect to f frame and x dash, y dash, z dash in respect to f dash frame. Similarly, if the particle is in motion, then the component of velocities are ux, uy, uz with respect to s frame and ux dash, uy dash and uz dash with respect to f dash frame. So these are the velocity components, that is ux is equal to dx upon dt. We know that velocity is the rate of change of position or displacement with respect to time. So ux is this, similarly uy is this and uz is this, dz upon dt. And ux dash is again dx dash upon dt dash, uy dash is equal to dy dash upon dt dash and uz dash is equal to dz dash upon dt dash. So here t and t dash, they are not same. T is also variable. X, y, z are variable and t is also variable. I am using the inverse Lorentz transformation equations of space and time. So it is not compulsory. We can prove this formula by direct equations also. If we use direct equations, then we will get the same answer. We will get direct equations of velocities. But I am using here inverse equations, so I will get the inverse velocity equations. So you can interchange direct and inverse equations by the given conditions which I have already discussed, that is s to s dash or s dash to s, or velocity changes to minus v. So these are the equations for position and time in f and f dash frame. We know on differentiation dx is equal to dx dash plus v into dt dash upon 1 minus v square upon c square under root. So this is obtained from the previous equation number 2 by taking its derivative on both sides. Similarly, dy equal to dy dash, dz equal to dz dash, that is here, and similarly dt is equal to dt dash plus dx dash upon v upon c square over 1 minus v square upon c square under root. So these are the differentiation or derivative of the equation number 2. From equation number 1 and 3 we have, that is 3 and this is 1. On combining or putting the value of 3 in 1, we will get ux is equal to dx upon dt. That is first. Ux equal to dx upon dt. So dx and dt, that is the value of dx and dt are putting here. By taking dt dash common from numerator and from denominator, and dt dash will cancel out and remaining terms are these, and finally it is ux dash plus v, this is ux dash over 1 plus v into ux dash upon c square. So this is first equation for velocity, that is equation along x-axis. Similarly, equations for y-axis, that is uy is equal to uy dash into 1 minus v square upon c square under root over 1 plus v upon c square ux dash, and hence also uz is equal to uz dash into this factor over 1 plus v upon c square ux dash. So this is second and is third equation of velocity. Here ux, uy, uz represent the relativistic laws of addition of velocities. So on combining, all these equations have written here, that ux is this, uy this, uz is this. So we can obtain the direct equations by changing the coordinates dash into without dash and without dash into dash, as I have discussed in the previous lecture, and also v to minus v. So we will get these equations, that is v is changed to minus v, and this dash, here is dash is not here, and there is no dash but dash is here. So on interchanging by using the same conditions, we will get these direct equations. So these equations can also be proved by taking the direct space-time equations, and we will get directly these equations. So but these equations can be interchangeable. Now the special cases for the velocity, that is velocity of light, that is c, is absolute constant. We know that absolute. What is absolute? It is always constant. It never changes with the motion of any other particle or any other frame. First of all, I will discuss case number 1. What is the first case? If ux dash is c, c means velocity of light, ux dash is velocity of the particle along x-axis in f dash frame. If that velocity is c, velocity of light, then we will use the first equation, velocity equation, that is ux is equal to ux dash plus v upon 1 plus v upon c square into ux dash, which we have proved by putting the value of ux dash is c here c, and here also c. On solving, on taking LCM, finally by cancellation, after cancellation, we will get again c answer. So what is the meaning of c? You have seen in this equation that if ux dash is c, then ux also c. What is the physical meaning of this c? It means the velocity of particle along x-axis in f frame is c, then the velocity of particle in f dash frame along x-axis is also c. It means if the particle is moving with velocity of light, then there is no transformation of velocity. The velocities of that particle in both frames is always same. So this is called constancy of light or absolute constant. So from equation, it is clear that the speed of light is same in all inertial frames. It will not depend upon the motion of the frame. Case number 2. Second case, when ux dash is equal to c is equal to v, it means the velocity of the particle in f dash frame and velocity of this frame, both are c, means the frame as well as particle both are moving with the velocity of light. Then what will happen? Then by using again equation ux is equal to ux dash plus v upon 1 plus v upon c square into ux dash. So putting the value of ux dash is c, v is also c. So we will get ux is equal to c plus c over 1 plus c into c over c square. And ultimately, by taking LCM and after cancellation, we will get c. This shows that the addition of velocity of light to the velocity of light merely reproduce the velocity of light. Means you have already learned in the previous classes, maybe 10 plus 1 or 2 classes, that if we add velocity of light c plus c, then answer is again c. It is not 2c. If we subtract c minus c, again answer is c. It is not 0. It means velocity of light is independent. So that law of velocity, the constancy of velocity, is proved here. So the velocity of light is absolute constant. So we can say that velocity of light is always constant. If you compare the equations for velocity with equations for position and time, then these are the comparison. This is the comparison. That is, ux dash is this, x dash is this. Y is same, but y is changing. Z is same, but z is changing in velocities. And if it is time, it is no time. Because velocity, in velocity, we have already divided the x with time. So where gamma is 1 over 1 minus v square upon c square under root. That is relativity factor or Lorentz factor. So this is the equations for velocities. So thank you very much.